Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, welcome to our class. So, last class we completed chapter 10 and today we will be seeing chapter 11, gravitation. So, all of us must know what is gravitation. So, on the earth, if you drop an object from a height, it falls towards the earth. Okay, if you drop an object, it falls towards the earth. So, this is due to some force that is called as gravity or gravitational force. In this lesson, we will see about gravitation, force of gravity, motion of bodies under the influence of gravity, and also we'll see about buoyancy and Archimedes principle. So, first one is force of gravitation. So, in our everyday experience, the bodies thrown vertically upward come back to the earth. The bodies thrown vertically upward, they come back to the earth. Even if the body or an object is dropped from some height, it falls towards the earth. Similarly, tree leaves and fruits, they fall towards the earth when they are separated from the branches. So why it happens? Because this is due to some force that acts on this body, like leaves or fruits. Okay. So Newton was the one who first discovered about the gravity. Okay, so he said that there is a force that is makes these things fall towards the earth. So, for example, they have given an activity here. You can read about this and understand. Okay, like a stone is dropped from a height, and then the same weight stone is dropped from a different height. So they want to uh, make us understand if the speed is same. Obviously, the stone which is dropped from higher height is going to have much force due to the force of attraction increases. Okay, the increase in the force of attraction. The next is going to be Newton's law of gravitation. So Newton, based on his observations, he expressed the law of gravitation. Law of gravitation in the language of mathematics. So his law is that every particle in the universe attracts every other particle with a force. Every particle in the universe attracts every other particle with a force, and this force is proportional to the product of their masses. So if you take here, there is a two object here. First one is m1, that is the mass is m1. Second object with mass m2. So the force between these two particles or object is proportional to the product of their masses. So you multiply the masses, these two masses, and inversely proportional to the square of the distance between them. So inversely proportional to the square of the distance between them. So the distance here is r. It is denoted by r. So square of the distance is r square. So inversely proportional. So it will come as a denominator. So now we will introduce a constant of proportionality, that is G is the constant of proportionality, which makes it equal to, so G m1 m2 r square by r square. So this is the Newton's law of gravitation. So now the gravitational constant, the constant of proportionality, G is very small. The value is 6.67 into 10 power minus 11 Newton meter square kilogram power minus 2. This is same everywhere. Okay, so this is the value of the G. Now, let's say that the force of attraction between you and your friend sitting on the next bench at a distance of 1 meter apart. Okay, so here let's say this is 40. This is 40, and your friend is also 40 kg. So how to find? We apply this formula. F is equal to G value is 6.67 into 10 to the power minus 11 into product of the masses. Your weight is 40, your friend weight is 40. The distance is 1 meter, so 1 square. So the value is this one. So likewise, they have given an example problem. You can just apply the formula and find out it. So the gravitational force due to the earth is also known as gravity. So the gravitational force due to the earth is also known as gravity. So gravitational force, gravity, same. The next topic is acceleration due to gravity. So acceleration due to gravity. We have seen that the speed of a falling stone, the speed of the falling stone, it increases continuously. It increases continuously. So this is due to the act, that is the stone, when it is here, then it comes down, the speed increases because it is accelerated due to the force of attraction between the stone and earth. The force between the stone and the earth, it is accelerated due to the force of attraction. Force of attraction. So they want to give a special name to this. So they call this kind of acceleration as the acceleration due to gravity. Okay, so this is called as acceleration due to gravity. So Galileo, what he did was that he dropped different objects from the Leaning Tower of Pisa in Italy to prove that the objects of different masses fall at the same rate. So if you take a bigger stone and a little smaller stone, if you drop it from a same height to the earth, once this it reaches the earth, both will reach at the same time. So according to him, that objects of different masses, they fall at the same rate. Okay, but if you throw a paper and then a stone at the same height, the paper will fall slower than this stone. Why? It is not because due to the mass, but due to the friction that happens to the paper, like air friction, wind friction that happens to the paper, that makes this falling down rate slower than the stone. So that you have to understand. The SI unit, so for this acceleration of gravity, acceleration due to gravity, they've given a symbol called small g. Lowercase g is the symbol, and the SI unit of g is same as the acceleration. The SI unit of acceleration is meter second per minus 2. So the acceleration due to gravity, the SI unit is same. So now here the acceleration due to gravity is denoted by g, that we know. To find out the force, uh, what they are doing is force equal to mass into acceleration. So we know that force is equal to mass into acceleration, which is a. But now here we are replacing this acceleration with the acceleration due to gravity. So this a will be replaced with g. So here F is equal to mg. So now what we are going to do, we are going to take this formula here, and we are going to replace this with here. So mg equal to, from that formula we take this one. So it comes like this, r square. Now once we cancel m with m, so what is remaining? G is equal to g m r square. Okay, so this small m will be cancelled. So remaining will be small g is equal to capital G capital M by r square. So this is the formula, final equation we get. So now if the mass of the earth is m and the r is the distance between the object and the center of the earth, but if the object is on the surface of the earth, so the distance r will be equal to the radius of the earth. Get it? Because if a person or an object is on the surface, this is the earth and this is the radius of the earth. Now there will not be much radius here in this object, so it will become the radius of the earth, single entity, so it will become gm by r square. Okay, the next topic is motion of an object under gravity. So there is an object and its motion under gravity. We know that g is constant near the surface of earth. On the surface of the earth, the gravity is constant. So all the equations for uniformly accelerated motions of bodies become valid when acceleration A is replaced by g. So according to the chapter 9, I mean, we discussed this, that is, Apasha discussed this in chapter 9. The acceleration formula here, V, the uniformly acceleration motion of bodies formula here, V is the final velocity is equal to initial velocity plus acceleration into time. So this is the formula. If you go back to chapter 9, you can see this. That is, final velocity is equal to initial velocity plus acceleration into time. So that is, now we are replacing this acceleration with acceleration due to gravity, which is g. So it becomes v is equal to u plus gt. And there is another formula from chapter 9, that is s equal to, s is the distance covered in time t, distance covered in time t. So s equal to ut plus 1 by 2 g t power 2 t square. So this is another formula. Now we are going to do a simplification. So what we are going to do is that this v is there, right? We are going to square this. So v square. So what will happen? This equation also will get power 2. So okay, you get it? V square is equal to u plus dt whole square. Now we are turning this equation like this. Now we are going to simplify this. How we are going to simplify? V square is equal to, there is a formula called for this here, a plus b square. This formula you must have studied in your previous classes. A plus b whole square is equal to a square plus b square plus 2ab. We are going to apply this formula here. So u square, that is a square, plus b square. B square is gt square. So gt square we can write it as g square t square. Then 2ab, 2 u g t. This is 2ab. Okay. So then what will happen? Q square plus, now we are going to take this as common. What we can take here as common? We can take we can take t as common here. Yes, we can take t as common here. Plus t common, so it becomes g. Okay, let's take gt common here. So gt we take. So here gt will be there plus 2u will be there. Okay. Wait a minute. I think there is a mistake here. Let me check the equation. Maybe I'm wrong here. Okay. Let me erase it and explain once again. So what am I going to do is that Now we are going to convert this equation V is equal to U plus gt into V square. So it becomes U plus gt whole square V square equal to U plus gt whole square. Okay. So now we apply this formula A plus B whole square formula. So it becomes V square is equal to U square plus G square T square, that is B square plus 2AB, so 2 UGT. So now we are going to simplify it. So how we are going to simplify? U square plus, we take the G as common here, so it will become G T square plus 2 UT. Now what we are going to do? We are going to take 2 as common. So U square plus 2G. Since there is no 2 here in this, so it will become 1 by 2. 1 by 2 GT square plus, here if we take 2, only UT will be remaining. So UT will be there. Okay. So now if you see the S here, it is S equal to UT plus 1 by 2 GT square. So you can see same UT plus 1 by 2 GT square. So same S equal to this one. So we can replace S here. So what will happen? V square is equal to U square plus 2G, then S will replace here, so 2GS. Okay, I hope it is clear. It is very simple. Just since we don't have board here, so it might look difficult to you, but if you listen multiple times, it will be easy, inshallah. So the same formula, if we apply to these examples and work out these problems in your notebook, inshallah. And the next is mass and weight. So the mass of a body is the quantity of matter contained in the body. The mass of an object is constant and it does not change from place to place. So there is a difference between mass and weight. Mass is the quantity of matter contained in the body. So the mass of an object is measured with the help of a pan balance. And we also learned in the previous chapters that mass of an object is the measure of inertia. The inertia is on the object. Weight is different. So the weight of an object is the force with which it is attracted towards the earth. The force in which an object is attracted towards the earth. So the force equal to mass into acceleration. So what we said, weight is the force of the object attracted towards the earth. So force and weight is equal. So W, which is weight, is equal to mass into gravity. Gravity is the force which attracts the mass. So weight equal to mass into gravity. So that is the equation for weight. And weightlessness, if you have noticed that while in the lift, while you go there, increase in the weight while in moving in the lift or elevator upward. If you, once you go, you feel that there is an increase in weight. But once you go downwards, the weight is, you feel that the weight is decreased. This is due to the force which is acting upon the mass, which is us. Okay, so that is what is called as weightlessness. That's why astronaut, they feel weightlessness in the space. Okay, they have given some activity examples here. You can read about it, inshallah. And the next topic is buoyancy and Archimedes principle. So let's say there is a tub, inside water is there. You lift an object, you lift it here, but once you keep it inside, and when you try to lift this object inside the water, you will feel some weightlessness or there is a push. So this is what is called as buoyancy. So they will give an example. That is, take a wooden block and immerse this in the water, and once you leave it, so what will happen? There is a force that pushes this wooden block upwards. So this is basically the upward force exerted by the water on the wooden block, like this, is known as the force of buoyancy or buoyant force. This is what is called as buoyant force, and this force is also known as upthrust. So you know why it happens? Because we will study here. So there is a spring balance like this. It's a spring balance. It will be like this. So if you tie a stone or an object like this, and if you keep it in the air, it will have a stretch like this. But the same spring, same stone, and with the same length of the thread, if you keep it inside the water, you will see that the spring did not stretch much, because this is due to the buoyancy there in the water that pushes this stone little upwards. So this is what is buoyancy. So Archimedes discovered this principle. So according to the principle, Archimedes is a scientist. So according to the principle, when a body is immersed fully or partially, in a fluid, it experiences an upward force. It experiences an upward force that is equal to the weight of the fluid displaced by it. Let's say there is a water is there. Now, if you immerse an object inside, okay, so here there must have been a fluid here in this space, but now you are replacing this fluid with this object. So the fluid will push this, the fluid that is displaced from here will push this object upwards. So that is what is Archimedes principle. When a body immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Okay. And also, according to Archimedes principle, the magnitude of the buoyant force, the amount of buoyant force acting on a body, it is also depend on the density of the fluid. How what is the fluid density? It also depends on that. And also the volume of the body immersed in the fluid. The volume of the body immersed in the fluid. So Archimedes is a Greek scientist. He uh, he found this principle, discovered this principle. So yeah, we have completed this lesson. So in-text questions and terminal exercise, all these things you have to do it. Take your time and do it, inshallah. We will have to complete the lessons very soon, because your exams are approaching. Maybe this time it will be, they will delay it little, I think so. But we will complete before March, inshallah, all the lessons. And then if you have time before the last working day, we will review the lessons, and I will tell how to study and what all to study, everything, once we complete all the lessons. And as usual, you have to write this as notes and send it to me, inshallah. Okay, see you all. Assalamu alaikum wa rahmatullahi wa barakatuh.